Okay, 8 in 7, lesson 9, moving along in unit 7, decimal expansions of fractions, part 1. So what we are going to do today is we're going to learn how to do estimations based on repeating decimals and use those in various calculations. And then we're even going to do this thing that might be hard for you. It's very tricky on problem set. Problem number 2, we're going to do an example that's just like it. So if that's giving you any trouble, that homework number 2, you can fast forward to the end of this video and I'm going to give you an example just like it. Let's move on and get to our sketch pad and begin to understand what it is we're doing this lesson. Okay, so we're going to approximate numbers to the nearest 10th, 100th, 1000th. This is something you've done before, I think. And why these approximations are within. I'll give you a little bit of understanding of why those approximations, if we round to the nearest 10th, it's always the biggest error is 1/10. And if we round to the nearest 100th, that's going to be within 1/100th of the actual answer. Okay, we'll see if we can give a good understanding of that. If we don't, I failed, but I'm going to try. And then we're going to use those approximations to perform some various math operations. And that'll be slide 2 and 3. There's really only 3 slides in this lesson. Okay, so let's talk about rounding this guy to the nearest 100th, and this guy here to the nearest 10th, and this guy to the nearest 1000th. So the first thing to do is to recall which digits are which. So after the decimal, you know, this would be the 10th digit. This would be the 100th digit, and this would be the 1000th digit. So in this case, we're rounding to the nearest hundredth. So we're going to want the 100th digit, which is this digit. I'll just underline it real quick. And down here, we're going to round to the nearest 10th, so we're going to round to this digit. And over here to the nearest 1000th, and that's going to be this digit. And as we know, when we round, we kind of there's one way to do it. We put a box around the numbers we're going to round. And that's the number of digits that are going to be in our answer. And then we also have to then inspect this number to know whether we go up or down. Okay? So our answer is going to be 0.9. And then it's going to be a 1 if this digit is between 0 and 4. We round down, and if it's between 5 and 9, we round up. So this digit here is between this 2 is a lower number, so this is closer to 0.91 than 0.92, so our answer is 0.91, and we'll put a box around that because that's our answer. Now the question is why, if we round to the nearest hundredth, is our error at most 1/100th? And some of you can maybe just see why, but let's see if I can try and explain why. So this number up here, and we did this earlier in maybe lesson 6 or 7, is 9/10 plus 1/100 plus 2/1000 plus 3/10,000 plus 4/100,000. All right, we did this exercise. ... We got one more number, but I won't bother. So if we look at our estimation is just this: 9/10 plus 1/100. Let me write the last one in here just for completeness sake. 4/1,000,000. So how far is our estimation? Our estimation and our actual number, they're off by this amount. This is the amount that's different. This is the amount above our estimation, right? Because if we subtracted our actual number from our estimation, this is what would be left over. Well, the question is, how do we know that this is less than 1/100th? Well, so the answer is how do I know that that's less than 1/100th? Well, we know that 2/1000 we can divide both top and bottom. Let's say we divide both in top and bottom by 10. So now we have 0.2 over 100. Well, that's this. Now I'm going to take this and I'm going to divide top and bottom by 100. And that's not changing the value. So if I divide this by 100, I move my decimal 2 to the left, 0.03 over 100. And what is this? If I move my decimal 3 and I move my decimal here 3, I get 0.004 over 100. And here, if I move my decimal 1, 2, 3, 4, and here I go 1, 2, 3, 4, I get 0.0. Just a second. Sorry about that. 0.004 over 100. So what is this whole thing if I add it all together? Well, if I add all that together, it's 0.2344 over 100. And how do I know that that's less than 1/100th? Well, my numerator is less than 1. So 0.2344 has got to be less than 1.0 over 100. Right? So I know, so the idea is that this is going to be true. You can do this same trick no matter whether you're trying to prove that it's to the nearest 10th when you round to the 10th spot or 1,000th for the near 1,000th spot. You just take all the extra decimals and then you apply this reasoning to it. And then you show that that whole difference is going to be, in this case, would be less than 1/10. And in this case, that whole thing would be less than 1/1000th. So hopefully that made some sense. And I'm not going to go about proving the answer on these next two examples, but let's just round this guy to the nearest 10th. So let's take the 10th. This is our 10th digit, and then we got to ask our question about the next digit. So we have 1 point. It's either 7 or 8. Well, because 8, this digit is greater, it's between 5 and 9, we round up. So our answer is 1.8. Okay. Because we round up. Because B/C, because 8, well, let me just write because our 8 is between 5 and 9. Now we're going to round to the nearest thousandth, so we're going to take this. This is our 1,000th digit, and we say 10.012. And now we have to look at this 4 and see, well, is that between 0 and 4 or between 5 and 9? Well, it's between 0 and 4, so we just stay here at 3. And those are our answers. Let's lay down some nice happy cats for that. Haven't been doing happy cats in the last few lessons. Okay, so now let's move along. These are questions that are asked to us regularly, and we need to figure out what is x plus y. If x is this and y is this, what is x plus y? Well, we can't just add those together. Now look why we can't add those together. Because if I do something like say, well, 0.6366363 ... and I try to add to that 1.88888888. Well, where do I start? Well, if I keep going, if I start with 3s, I'm going to end up with a 1, but then I didn't add up all these digits over here. And if I went 8 and I went 6 and I went 8, I'd have a 4 over here instead of a 1 over here, and I'd carry my 1 and I'd end up with a 2, and then I'd carry my 1 and I'd get like an 8. So I don't know what I'd get. You can't add numbers that repeat forever. You can't really do it. So what we have to do is I can't know. Sad face. Or sad face. Can't know. Can't add decimals with infinitely repeating decimals. So we can't approximate. So let's round these guys to the nearest tenth. Well, this guy rounded to the nearest tenth. We're going to do our trick here. We'll say, well, we're going to estimate x, and we're going to say, well, that's 0.6. And we're going to estimate our y, and we're going to take our y to the nearest tenth. And then that turns out to be 1.9. About 1.9, because we have to round up due to this 8 being bigger than 5. So now we can estimate, well, let's estimate x plus y. Well, that's 0.6 plus 1.9, and that's equal to about 2.5. So that's our estimate. Now we're going to estimate 2x plus y. Well, 2 times x is 2 times 0.6. We just plug in our x, right? 2x plus y. Put our x in, we put our y in, plus 1.9, and we get 1.2 plus 1.9, and we get 3.1. So that's how we do these kinds of exercises. We round, and then we estimate. And I think, let's just do another one, because I know that you may be asking this question. Let's try 1/3 x plus 2y. Make it a little bit trickier. So then we'd say, well, 1/3 times 0.6 plus 2 times 1.9 equals, well, 1/3 of 0.6 is 0.2. If you do the math on that, plus 3.8. So you know, there's 4. And these, again, these are estimates. These are estimates. Okay. And you work a number of these in class today. So let me jump forward to the last key thing, using these estimates, and it's a really cool trick. So we have, and this is like homework problem number 2. This is like problem set number 2. I'm going to do this one in blue, my favorite color, because I love this problem so much. So here we got to do, we're going to round these guys to the nearest 100th, and then we're going to estimate y over x, and then we're going to estimate 5x plus 1/3 y. We're going to do these 2 calculations after we've done our estimation. So let's do our estimation to the nearest 100th. And so this guy is about, we have to look at this 7 and say, oh, well, we have to round up, so 0.16. And here we got 0.63. So let's estimate y over x. Okay, so 0.63 over 0.16. Well, before we even do our division, I'm going to multiply top and bottom by 100 to make this easier to do. So I'm basically moving my decimal 2 to the right, so we get 63 over 16. Right? That's easier to divide than 0.63 than 0.16. So now let's use our box top. Box top. I forget which one to put inside the box, but the one on top, this is our top, 63. So that goes in the box. 63 divided by 16. Put my decimals down. So that's 3. 3 times 16 is 48. That's 1, 5, 0. So that's 9. 9 times 6 is 54. 5, 14. 6, 60. That goes in 3 times 16 is again 48. 120. 16 into 120 is 7. 7 times 16 is 2, carry 4. And then we get 80. 16 into 80 is 5. So there's our estimate. So y over x, we estimate to be 3.9375. So bear with me. This is all really important. This is really like problem set number 2. So now we're going to estimate 5x plus 1/3 y. So x is again 0.16. So 5 times 0.16 plus 1/3 of 0.63 equals. So this is 0.8. 5 times that is 0.80. And 1/3 of 0.16 is 0.63 divided by 3, which is the same as 0.21. So that equals 1.01. Okay. If you have struggle with this math, you need to do your 5 times 0.16 and do your long multiplication. And if you struggle with 1/3 of 0.63, you got to take 0.63 divided by 3. And then you end up with box top, 0.63 divided by 3, and you get 216,031. So there's your 0.21. So just wanted to make sure you remember how to do that math, get your decimals right. Okay, so this is what you do on the first 2 parts of problem 2, problem set number 2. Now the next thing is I said, what if I told you that y over x and 5x plus 1/3 y were actually both integers? So my estimates are close to my answers, but what if I said they were both actually integers? What do you think x and y could be? Now here's the key, the whole key to that problem. It sounds tricky. First of all, let me give you some happy cats for getting those guys right. Now the whole key is that if y over x is an integer, and y over x estimated is 3.9375, what do you think y over x could be? It has to be an integer. So is y over x, question mark, does it equal 1? Does it equal 2? Does it equal 3? Does it equal 4? Question mark. Well, if I estimated it and I got really close to 4, this is close to 4. So I'm going to say, well, y over x is equal to 4, because I'm telling you that I know that it's an integer. That's something that the problem gives you. And now I said, well, 5x plus 1/3 y is an integer. Well, if 5x plus 1/3 estimated is 1.01, then what do you think it is? Well, I think 5x plus 1/3 y is equal to 1, because the estimate is really close to 1. So now let's write that out. 5x plus 1/3 y equals 1. So these are the 2 things, these are the 2 starters that are going to help me figure out what x and y might be. So what does this look like? This smells like something I've seen before. And the answer is a system of equations. So if y over x equals 4, then let's do a cross multiply to make this really look familiar. So y over x equals 4 over 1, cross multiply, and I get y equals 4x. Okay? Now down here, I don't like this equation written like this, so I'm going to multiply. And remember, if you struggle with this, go back to Unit 4 where we saw system of equations. And one thing that you can do is you can say, well, I want to get rid of all my fractions, so I can actually multiply by this denominator here. And we're going to multiply this left side by 3 and this right side by 3. And I'm going to get distributing 3. 3 times 5x is 15x. plus y equals 3. So now I have 15x, or I could say, well, y equals 3 minus 15x. Let's just do that for a second. And now I have these two equations, and I can use substitution, because if y is equal to 4x and y equals 3 minus 15x, I could say, well, 4x equals 3 minus 15x. Right? If y is 4x and if y is this and y is that, then this must equal that. So let's add 15x to both sides. And we get 19x equals 3. And so x equals 3 over 19. Wow, this is looking pretty cool. So if x equals 3 over 19, and y equals 4x, we're going to plug back in here, and we'll say, well, y is equal to 4 times 3 over 19. So y equals 12 over 19. Oh my goodness. So that's what I think my answer is. Now what I want to do is write this down. X equals 3 over 19 and y equals 12 over 19. And we're going to go to our calculator, and we're going to see what these things might equal. So let's go back. Watch this. We're just going to go really quickly, and we're going to now screen share our calculator window, and we're going to see. Let's test out. Uh-oh, sorry about the glare there. Three divided by 19 equals, let's write that down, 0.15789,473. And let's do 12 divided by 19 equals, 12 divided by 19. So let's write down those two numbers. Write down 0.15789 and 0.631578. And now we're going to come back and see if our numbers were right. There we go, back to our window, and we find out that yes, our numbers were right. We did the right calculations. That's pretty cool. So, right, 3 over 19 does equal 0.1579 ... and 12 over 19 equals 0.63157 ... So that's part D, checking our answer. So you can do this same strategy here when you're doing your homework, and you can hopefully impress your teacher. This isn't the problem itself, but it gives you an idea of how you can go about solving that problem if you have the persistence and the wherewithal to work through this. There's a lot of building blocks in this problem and a lot of tricky calculations, but for you who are loving math and enjoyed this lesson, this strategy can work for you to get 100% on your homework. Okay, well, let's just head back to our goodbye screen and just say goodbye from, ADM 7 lesson 9. Very good stuff. I really like that last problem on the problem set. So hopefully you did too, and hopefully you struggle with it and persist and get that answer right on your homework tonight. And we'll see you next time with ADM 7 lesson 10.